So this is HeFPipe video 3, and in video 3 we'll talk about the input files. So in order to run HeFPipe, a few input files are required, and a template of each of these files comes with the example data. You can see a template of each of these here. And the first of these files is the address file, which is a comma-separated values or CSV file, and it's called addresses.csv in the example dataset. And it contains the paths for all of the other input files. So note that you shouldn't include quotation marks for the paths designated in this file. So this is what the file looks like. We open it up, and the first column you won't change as the user, right? It's the name of all of the other input files, and column B is the one where you enter the path. So notice there's no quotation marks, and every file that is a directory ends in a backslash, right? And all the file extension names for all the CSV files end with, CSV. The second input file is a directory, and it's called allele reports in the example data set, and it contains all of the allele reports from gene marker, but note that they are in CSV format. They're not in Excel format. So here's the allele reports directory. And this is important. The allele reports need to be in the marker table style as opposed to the peak table style from gene marker. So gene marker gives you these two options for output: pick marker table, not peak table style. I'll talk about this a little more in the next video, but the first file in this directory, right, so this file, in alphabetical order, the first file, must contain all samples listed in the other files. So in other words, the samples in the other allele reports are permitted to be subsets of the samples included in this first allele report. If this is not possible for your data set, don't worry about it. I have a workaround that I'll talk about in the next video. But let's take a look at what an example of these gene marker files looks like. So you'll have the names of all of your samples in this column, and you'll have each of your marker loci in these columns. The third input file is a CSV file called keeplist.csv in the example dataset, and it contains a list of every microsatellite locus that will be used in the current run of the pipeline. So loci are listed in the first column of the spreadsheet. Let's open it up and take a look. Right, so loci are listed in the first column of the spreadsheet. There's no header, right? You just start with locus names. And there's one locus for each row. So the HeFPipe pipeline will throw errors and arrest if a locus with no polymorphism is included in keeplist. So unless you're actually looking for a convenient way to identify loci without polymorphisms, don't include loci without polymorphisms in keeplist. But that said, it is an easy way to find loci with no polymorphism. Okay, the fourth input file is a CSV file called monolist.csv in the example dataset, and it contains a list of every microsatellite locus that is contained in the allele reports that will not be used in the current run of the pipeline. So this is the complement to keeplist. This exclusion may be because the loci are monomorphic or difficult to score, and it's intended to save the user time by not having to omit these data manually from all of the other allele reports, either during or after scoring. So when we open monolist up, you'll see it's exactly the same format as keeplist, but it contains none of the same loci. So these are all loci that we excluded from analysis for one reason or another. It's a long list in our case. Now the output files of the pipeline will be saved into the fifth input file, which is a directory. And in the example data, it's called pipeline. And again, all of the output from the pipeline either gets saved in this directory or subdirectories within this directory. And don't worry for right now about the 3 files that are contained in this directory. The user creates this directory manually and provides the path in addresses.csv. Actually, that's true for all of the input files. Now the 6th input file is a CSV file, and it's called rejected-samples.csv in the example dataset, and it contains a list of every sample that will be excluded from the current run of the pipeline. 1 sample per row in the first column, again with no header. Now in my experience, these excluded samples have included samples that ended up being triploid based on their microsatellite genotypes, or for which the DNA extraction failed. And there will of course be any number of reasons that you might have to exclude certain samples for various runs of the pipeline, and the samples to exclude file is supposed to make this an easy job to accomplish. By the way, in case you have to deal with triploid samples in your system, triploid scores for loci in keep list, right? So if you end up having 3 genotypes at that locus, it gets flagged by the pipeline as being problematic, and users will be asked to either delete the extra column for that sample in the relevant allele report before moving on, or you can delete the genotype entirely of the offending individual at that locus. And as long as that individual or sample is listed in the samples to exclude file, these actions will have the same outcome. It's also important to note that samples can be listed in the rejected samples list for reasons pertaining to either its genotype or one of its traits, or several. And the script will make sure that the rejected samples will be excluded from relevant analyses either way. So this allows users to avoid the tedium of making sure that the samples are disabled from every single allele report. With that said, it may require some thought about which samples should be rejected outright and which ones should simply contain missing fitness and/or genotype data. So the user should bear in mind that there is a portion of the pipeline later that allows you to generate and run regression models on subsets of the data. So for example, if you only want to run the pipeline on individuals that are infected by a certain virus or something like that, the pipeline is actually equipped to deal with that, and we'll talk about that in a future video. So again, this is what rejected samples.csv looks like. It's just that first row, and it contains the IDs of all of our samples. Okay, the 7th and final input file is the trait file. And in order to conduct a heterozygosity-fitness correlation, at least 1 trait must be provided, although the pipeline accommodates any number of traits. And this CSV file, which is called acceptor.csv in our example dataset, it contains these fitness data. With the sample IDs as numbers in the first column. So here are the sample IDs. This time note that there are headers, obviously, because you need something to specify which traits belong to which columns. And there's 1 trait per column. You should know that the trait data is permitted to contain samples that are not present in the genotype data, and vice versa. Missing data or even entire missing samples, that is, a row of data with only the sample ID and all NA scores across the board, are also permitted. And also for optimal results when the correlation heat map and correlation charts are generated, and we'll talk about that in a later video, the column headers here, so aka the trait names, in the spreadsheet should be as short and as informative as possible. So really long names here are not advised for aesthetic reasons for later on in the pipeline. And that's it.